Welcome to the Crazy Hat Chemist. So another video here on kinetics. Bam! So today we're talking about the graphics of a kinetics reaction. So this graph here, hopefully you can see, is concentration versus time. That's why the concentration is on the y-axis and the time is on the x-axis. So concentration, these are in percentages. So you see 100% there at the very beginning, and then that decreases all the way down to 0. And then the time, you should see it starts off at 0 seconds, and then it continues off onto 8 seconds. So let's check out a couple of things about this graph. So I've drawn a point here on this graph here, very high up, and then there's that line. Okay, this is an instantaneous rate. Okay, so that's that point on that line. It's not an average, it's instantaneous at that specific point on that graph. Okay, and this is the reaction, the rate law. So that is the rate law, the rate equation, that is R is equal to negative change in concentration of the reactants over change in time. Again, you should see that negative sign there. You should see that the concentration of the reactants decreases over time. Okay, here is another instantaneous rate. Okay, right there. And I've drawn that line there, that blue line, so that you can see the difference between the first instantaneous rate that I had on there and the second instantaneous rate. I want you to think what is happening between those two instantaneous rates. Okay, and here is another one, and maybe this one you'll be able to see what's happening here. Okay, so what do you think is happening to the instantaneous rate? Is it increasing, decreasing, remaining constant over time? Good question. I also want you to think about what is happening to the reactants over time and what is happening to the products over time. Okay, so the rate is negative because it's a decrease in the concentration of the reactants, and rate laws are always with respect to the reactants only. Okay, reactants and potentially the catalyst if the catalyst is involved, but never the products. Okay, the instantaneous rate is not the average, it is at a specific time point. Okay, and that's why there's that slope for each one that I've drawn for you. Notice that the instantaneous rate is fast initially with a steep slope, and it decreases over time or flattens out. So you should see those three instantaneous rate points that I have drawn. The first one on the top, okay, is a very, very fast rate, okay, and that means that that reaction is going very fast, okay, because that means that there is lots of reactants and zero products. But you should see that over time, and that bottom instantaneous rate, that means that there are fewer reactants to react, and then what's happening to the products, they're increasing over time. Hopefully you get that. Okay, so what would be expected to happen to the products over time, right? You should see that you would have no products to begin with, and then the products will increase over time. So that's what this red graph here is. And there's an intersection between the reactants decreasing and the products increasing over time. And wherever that intersection is, that's when you have the same amount of reactants and products as far as the rates. Okay, that is the rate of the reactants decreasing and the rate of the products increasing at that moment in time. But you should see that the rate of the products being produced is very fast initially also, but it decreases over time because you have fewer reactants to react, and that takes more time for those reactants to get together. So if you imagine like a classroom full of students, you have some males, you have some females, and they all have to form a couple together. So once you start forming couples and they leave the room, then there's fewer and fewer individuals to form couples over a period of time. And so that's why the reaction takes a longer period of time. Okay? Initially, there are no products, but as the reactants decrease, the products increase. Hopefully that graphic makes sense to you. I want you to take a look at that graphic and spend some time observing that, looking at it, reworking through it for you, and look at that instantaneous rate. Okay, I am the Crazy Hat Chemist, and I got a great hat here for you. If you're part of the Oregon Ducks, of course, you're going to love this hat. Quack, quack. Okay, give me a thumbs up if you like that video. Give me a thumbs up if you like the hat. Subscribe to my YouTube channel and tell all your friends. And I'm going to see you next time for more cool chemistry videos. Bye for now.